Hey everyone, so today we're going to review a little bit about product rule and quotient rule and see how do we apply the formulas to find the derivative of certain functions. So basically let's start with product rule. Product rule is basically used for functions that are basically product of two functions, as the name suggests. For example, if you have f of x is of the form of g of x multiplied by h of x, that is an example of a function that is made up of a product of two different functions. Let's take for a direct example. We have f of x is basically sine x multiplied by 6x. So sine x is going to be our g of x. Meanwhile, 6x is going to be our h of x. Now, product rule is the derivative of f prime in this case. It is going to be g prime of x multiplied by h of x plus g of x multiplied by h prime of x. Now, usually in a lot of books and a lot of calculus lessons, they don't give you like g of x multiplied by h of x. They basically tell you that this is u and this is v. So now the rule becomes u prime v plus u v prime. So if we want to apply this on the example I gave you with sine x multiplied by 6x, so basically, first of all, you have to write that f prime of x is going to be, the derivative of sine x is going to be cosine x. That is going to be our u prime. V is literally the same as the 6x on top, so you rewrite it over here. That is going to be your V plus U is going to be sine x, and V prime, it is going to be 6. Now you just multiply these terms, so it will be 6x cosine x plus 6 sine x. Now, if you want to factorize, you are able to factorize. Of course, this is optional. Plus sine x. This is what happens when you take 6 as a common factor. So this is one example about product rule. But sometimes product rule can be a little bit more challenging, if you may. Because, especially in calculus, you can literally encounter functions that involve more than one rule at the same time. So I'm going to give you a challenging example. Having product rule mixed with chain rule. So this is one of the mixtures that you can get in derivatives, especially like in unit 2 of calculus, because there's a lot of rules that you have to understand before you memorize. Like, I don't recommend you memorizing any of the formulas. I want you to understand what you're doing in order for you to understand what kind of rules are you mixing. So over here, you're mixing the product rule with the chain rule. So I'm going to give you a function which is basically e to the power of x, for example, to the power of 2 multiplied by cosine 2x. So now, to derive this, we are going to use product rule. So the derivative of e to the power of x to the power of 2. This is of the form e to the power of u. And the derivative of e to the power of u is going to be u prime e to the power of u. So now the derivative of e to the power of x to the power of 2 is going to be 2x e to the power of x to the power of 2. This is going to be our u prime. And then v is going to be remaining the same. So cosine 2x, that is going to be our v, plus u, which is basically the same as e to the power of x to the power of 2. And v prime, this is going to be cosine u, and cosine u, the derivative of it is going to be minus u prime sine u. So it is going to be minus 2 sine 2x. So this is going to be my u and this is going to be my v prime. Now, if you multiply the terms together, you're going to get 2x e to the power of x to the power of 2 cosine 2x plus, actually not plus because we have a minus over here. So it's going to be minus 2e(x to the power of 2 sine 2x. Also over here, if you want to take 2e to the power of x to the power of 2 as a common factor, you are able to do so. So 2e(x to the power of 2 x cosine 2x minus sine 2x. This is basically the derivative of this given function. Now, this is basically it for product rule. This is literally the most challenging part about product rule is actually having it mixed with another rule. You can also have another mixture between product rule and quotient rule at the same time. And that is going to be like a very long derivative. Although let's keep that for another video. Let's move forward with quotient rule. Quotient rule is basically when you have a function as a quotient of two different functions. So let's say that f of x is equals to u over v, where u and v are two different functions. The rule suggests that f prime of x is going to be u prime v minus uv prime over v to the power of 2. This is basically quotient rule. I'm going to give you a direct example over here. So let's say that we have f of x is equal to, let's say, ln x over x. So f prime of x is going to be, so this is going to be our u and the denominator is going to be our v. So u prime is basically the derivative of ln x, which is basically 1 over x multiplied by v, which is x, minus ln x, which is our u, and v prime is basically the derivative of x, which is 1, over v squared, which is x to the power of 2. Now notice over here that you can cross x with x, so you're going to get f prime of x is 1 minus ln x over x to the power of 2. This is basically our final answer. Similar to product rule, you can make it a little bit more challenging by introducing more rules together. Like for example, let's do the same exact criteria as product rule. Let's mix quotient rule with chain rule. So now let me give you an example of a function. Let's say we have f of x is equal to 2x plus 3, all of it to the power of 3, over, let's say, x plus 1, all of it to the power of 2. So this is going to be my u and the denominator is going to be my v. So f prime of x is going to be u prime, which is going to be 2x plus 3, all of it to the power of 2. According to chain rule over here, we have to multiply by the derivative of whatever is inside. So we have to multiply by 2 because the derivative of 2x plus 3 is going to be 2 minus, sorry, not minus. So this is all of it is our u prime v. So x plus 1 to the power of 2 minus u, which is 2x plus 3 to the power of 3. And v prime is going to be 2x plus 1 multiplied by whatever the derivative inside, which is over here basically equal to 1 as well. All of this is going to be divided by v to the power of 2. So x plus 1 to the power of 2, all of it to the power of 2. Now we rearrange the function. So 3 multiplied by 2 is going to be 6, multiplied by 2x plus 3 to the power of 2, and by x plus 1 to the power of 2, minus 2 multiplied by 2x plus 3 to the power of 2, multiplied by x plus 1, all of it over x plus 1 to the power of 4. Now, if you notice over here, we have x plus 1 over here, x plus 1 over here, and x plus 1 over here. So we may simplify with x plus 1, but we need to make sure that x is different from minus 1. If they didn't say it in the question, or they didn't specify, that means you have to specify before simplifying and say that x is different from minus 1. The reason for you to saying this is because if x was equal to minus 1, then minus 1 plus 1 is going to be 0, and the denominator is not allowed to be 0. So, mission impossible if you do that. So you have to state that x is going to be different from minus 1. So removing one copy from x plus 1 from the denominator, you're going to be left up with to the power of 3. Over here, removing one copy, you're going to be left up with the power of 1. And over here, it gets removed entirely. So the final form of f prime of x is going to be 6 2x plus 3 to the power of 2, x plus 1 to the power of 1, minus 2, 2x plus 3 to the power of 2, all of it, x plus 1 to the power of 3. This is basically our final answer. If you have any questions, you can pause the video and you can write a comment and let me know. Thank you.